Hello and welcome back. I'm Konstantin, and today we're going to solve the most frequently asked question by Facebook in the past 6 months. I hope that by the end of this video, you'll fully understand the solution and you will be able to solve a variety of problems out there. Let's go through the description of the problem. Minimum remove to make valid parentheses. Probably this is not the most intuitive title out there, but let's give it a try. So we're given a string which contains lowercase English characters and parentheses, and our task is to remove the minimum number of parentheses in any positions so that the resulting parentheses string is valid and return any valid string. So here they kind of like give us the definition of what a valid parentheses string is. So if we're looking at the first example, we know that the first parenthesis cancels, so the second parenthesis right here cancels with this one, and then this one cancels with this one. So we're remaining with one, and all we asked is to return the string without that invalid parenthesis. And if we're looking at the third example, we could see that a valid response could be an empty string if we have to remove everything. And our constraints are lowercase, all the elements are either parentheses or lowercase English letters. So let's see how would we solve this problem. So if this is our string and we need to check all the parentheses, so we know that we would start at the beginning, right? And then we would end right here at the end. Obvious, pretty obvious, right? So we would probably have to do a linear time because we would have to go through all the elements in the string and check all these parentheses. So first, like if we're having, let's take an example, because right now we need to find out which parentheses are valid or not. So if we're having this example right here, how do we know if this example right here is valid or invalid? So we know that these two are canceling out, right? And then we're remaining with this one right here, so therefore is invalid. So my suggestion is that always when you use it almost as a keyword, so every time when you see a problem which is dealing with parentheses, probably the first thing that should come up to your mind is a stack. So in this case, we would just put all these parentheses in a stack. So if the stack contains an open parenthesis and right now we're getting to a closed parenthesis, we would pop them both and then we would add the last one, and as our stack is not empty, we'll return false. If our stack would be empty, then we'll return true. The only difference that is in our problem, we don't have to remove all the valid parentheses, right? We're asked to remove only the invalid ones. So that's why instead of adding the parentheses in the stack itself, we're gonna add the indices of where we find parentheses in the stack. So first we're gonna add our 3, and then we're gonna add 5, and then when we came to this 6 right here, we see that we already have an open parenthesis in the stack, an index, so we're gonna pop this 5. So let's think about this. Let's actually try to come up with a stack. So we will have a stack. So our stack is we're gonna start again at the beginning, and then we're gonna go through all the elements. So whenever we're gonna find an open parenthesis, we are going to add it into our stack. And always when you think about stack, think about a stack of coins on a table. So we only have access to, if we keep adding one coin right here and one coin and so on, the only thing that we have access is the top coin, right? We can't just go, at least in programming, we can't just go in the middle. It's illegal. So we need to always go from the top and get one coin. So this is how a stack usually performs, right? So if we're moving from the beginning and then if we're finding a character which is an open parenthesis, we're just gonna add it into our stack. So we're gonna keep going, we're finding another one, so we're gonna add it into our stack again, and now we're finding a closed one. So when we found a closed one, we need to check, do we have anything in our stack? Because if we have anything in our stack, it means that we already have an open one. So in this case, we have something in our stack. So what we're gonna do is we're gonna pop this element, we're gonna remove it from our stack, and then we're gonna keep going. And again, I added this parenthesis right here just for the illustration purpose, but we're gonna add the indices. So our stack, it will contain, first we'll add 3, the index 3, and then we'll add the index 5, and once we made it to index 6, we're saying that the parenthesis is closed and we already have something in our stack, so we're gonna decide to pop this 5 right here. So we're gonna move forward, and now we're seeing we do have another closed parenthesis. So the same check, do we have anything in our stack? And we do, right? So we're gonna decide to pop this element from the stack too. So right now our stack is empty, but we still have processing to do. We still have to go through this portion of the string. So we're gonna keep going. We're gonna go here and here and here. So right now we encounter a closed parenthesis. So we can't add it to the stack yet. So we need to check if our stack is empty, because if our stack is empty and we do a pop operation, we'll get an exception, right? So if our stack is empty, we need to mark this index right here, because for sure we know that this is an index where this parenthesis needs to be removed. So what we're gonna do, we're going to transform. We're not going to work with the string just because string is immutable. So for every single addition or subtraction or for any modification of the string, we'll create a new string. So that's why we'll work with string builder. So in string builder, we have a method where we could set a particular char if we have an index. So we'll use that method and we'll set char at, and we know we have this index already. So set char at position 11, and we could set it to anything. Let's say we'll make it a star. So right now, it will transform from this parenthesis into a letter star or whatever you like. Anything that's not a English letter, lowercase, or a parenthesis, anything that's different. So we're gonna do that, and then we still have this little portion right here. So we're gonna go to the next one, and now we're gonna go to this one. So we know that this parenthesis is open, right? So we could just go ahead and add it into our stack. So we also gonna add index 13 into our stack, and then that's it, right? We have nowhere else to go. So what we're gonna do now, we know that this is for sure we need to remove this parenthesis, but we also know that we need to remove this one right here. So it's very convenient to see that this index, it's still in our stack. So we're gonna go one more time through our stack, and for whatever method we called right here, we're gonna pop every single element from our stack. So right now we still have 13. So we're gonna do an SB set char at 13, and we also gonna set it to a little star or something like that. And after we've done that, this is also gonna become a little star. So all we have to do is reconvert this string builder into a string and replace all these stars with an empty character. And then that's all we have to do. Our final result will be exactly the same string, but whenever we've seen a little star, we'll replace it with an empty character, and then we'll keep going. And that's all we have to return. So let's go to Leetcode and let's code this very quickly. So we said we will work with string builder, so we'll have a string builder, and we'll call it SB, and we'll pass our string into it. And we said we gonna have a stack which is gonna contain integers, which will be the indices of the elements. So stack equal new stack. So after we've done that, all we have to do is start at the beginning and go all the way to the end. So we'll do this with a while loop, and we'll start at 0 and we'll go all the way until sb.length. And right now we need to perform some checks, right? So the first thing we said is we're gonna check if it's an open parenthesis, and if that's the case, we're just gonna add it into our stack. So if sb char at I is equal to a open parenthesis, all we have to do now is just add it into our stack. So we added that index into our stack, and now there's the other situation. So else if there is a close parenthesis, so sb char at I is equal to a closed parenthesis. So right now we're not gonna add it, but we're gonna check if the stack is empty so we can pop something out of it. So we said we have to check if the stack is not empty. Is empty. So if the stack is not empty, we'll pop one element from the stack. Stack.pop. But in the other situation where the stack is empty already, all we have to do is sb set char at I, and then we'll set it to a little star. And once we made it so far, right now we made it through all the iterations, so we need to check if we still have any elements in our stack. So while our stack is not empty, because if we still have any elements, we need to make those characters modifications too. We need to make them little stars. So while our stack is not empty, we'll just do sb set char at I, or not char at I, but char at the element that is in the stack currently. So stack.pop, that's the index that we'll have, and then we'll do exactly the same thing. And after this iteration, all we have to do right now is just our return statement. So we're converting our string builder back to string because that's what we're asked to return. And we said there's one more thing, the essential thing. We need to replace those stars with an empty character. So we will do replace all, and in here we will just pass our star, and then we'll pass an empty string. And that's pretty much it for this problem. Let's give it a try. SB, okay, just because I misspelled it right there. Yep, so it works. So in terms of time complexity, we are going through all the strings. So we're doing a linear search, so that's big O of n. So I hope you like this problem. I hope you learned this problem. I hope you'll remember that every single time, or almost every single time when we're dealing with parentheses, think about a stack as a data structure, because probably that could be the easiest way and your starting point. If you have any comments or any suggestions, please write them down in the comment section. And thank you for watching, and I'll see you in the next video.